All right, you are welcome again. Today we want to talk about exact equation, okay? That is differential equation that is said to be exact, okay? Now let's take a look at this question. Show that this equation is exact and solve it. Y squared minus 2xy plus 6x in bracket dx plus x squared minus 2xy plus 2 in bracket dy equal to 0. So we are asked to show that this equation is exact, and then we are to go further and solve this. Okay, now let's go. Here we have the side that is having dx and the side that is having dy. Okay, so this side that is having the x, we are going to call it a name, and then this side that is having dy, we are going to call it a name. So dx is going to be m, and then dy is going to be n. Okay, so that means we are going to say that m is equal to y squared minus 2xy plus 6x, and then n is equal to minus x squared plus 2xy minus 2. When you look at it, in that place we have x squared minus 2xy plus 2, the side that is having dy, right? Good. And it is the same when you multiply this x squared minus 2xy plus 2, when you multiply 2 by minus 1, it's going to give you minus x squared plus 2xy minus 2. Both of them are still the same. All right, good. So here we have m and then we have n. Okay, so the next thing we are going to do is this. We are going to differentiate m partially with respect to y, and then differentiate n partially with respect to x, and then see what we are going to have. So in the first one, when we differentiate m partially with respect to y, that means we are going to hold every other variable constant and differentiate only y. Okay, so that means this place we have y squared minus 2xy plus 6x. When we differentiate y squared, it's going to give us 2y. Then we have minus. When we differentiate 2xy, it's going to give us 2x. And then 6x is going to give us 0, right? Good. So that means we have the partial derivative of m with respect to y is equal to 2y minus 2x. All right, good. Now, again, let's also differentiate this n partially with respect to x. Okay, that means we're going to say the partial derivative of n with respect to x is equal to, when we differentiate minus 2x squared, it's going to give us minus 2x. And then when we differentiate 2xy, it's going to give us plus 2y. And then minus 2 is a constant. When we differentiate, it's going to give us 0. So the partial derivative of n with respect to x is equal to minus 2x plus 2y. Now, look at this. We have the partial derivative of m with respect to y, and then the partial derivative of n with respect to x. So looking at these two equations, we see that both of them are the same. Hello? We see that both of them are the same. We see that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x equal to 2y minus 2x. Then with this statement, we see that the equation is exact. With this, we say that the equation is exact. Now, the part that we say m and the part we call n. So when you differentiate m partially with respect to y and differentiate n partially with respect to x, if both of these partial derivatives gives you the same thing, we say that the equation is exact. Then we say hence the equation is exact. Now we go further to solve it. Okay, so for us to solve this, we're going to say let's look for a function. Let's call this function u of x comma y. So that means we're looking for a what? A function u of x comma y. And then let this function u be a function such that when you differentiate this function partially with respect to x, it's going to give you m. And when you differentiate this function partially with respect to y, it's going to give you n. Hello. That means we're going to have the partial derivative of u with respect to x is equal to m, and the partial derivative of u with respect to y is equal to n. Okay, good. Now let's go. That means we are going to have the partial derivative of u with respect to x equal to m. But we say that we know the value of m. We say that m is equal to y squared minus 2xy plus 6x. Is that true? So instead of writing m, let's substitute for the value, right? That means we're going to have the partial derivative of u with respect to x equal to y squared minus 2xy plus 6x. All right, good. Let's call this equation 1. Let's go further again. The partial derivative of u with respect to y, which is equal to n. But instead of us writing n, we say that we have the value of n, right? Let's replace it here. We're going to say that the partial derivative of u with respect to y, which is equal to m, but we substitute for m, we're going to have minus x squared plus 2xy minus 2. Let's call this equation 2. All right, good. Now, we are looking for the function u of x comma y, right? Good. Now, we can use any of these two equations and solve for the function u of x comma y. Which one are you going to use? We are going to, in this video, we are going to use the two of them and see whether we are going to get the same answer. Okay, firstly, let's use equation 2. Okay, so the equation 2 say the partial derivative of u with respect to y is equal to minus x squared plus 2xy minus 2. Okay, so this is partial derivative of u with respect to y. It is differentiated partially with respect to y. But we are looking for the function u. That means we are going to integrate this with respect to y. Hello. It is differentiated with respect to x, but we are looking for the function u. That means we integrate it with respect to y also. All right, good. That means we're going to say we integrate this equation 2 with respect to dy, right? So that means we're going to have the integral of both sides. The integral of the partial derivative of u with respect to y dy equal to the integral of minus x squared plus 2xy minus 2 dy. All right, good. When we integrate the left hand side, it's going to give us u. And then when we integrate the right hand side with respect to y, we're going to have minus x squared y plus xy squared minus 2y plus, we're supposed to have plus c, which is constant, okay? But in this case, we are not going to use the letter c. We're going to say t of x. Hello. We're going to say what? T of x. Now let's call this equation 3. I told you we are looking for the function u of x comma y, and we have found the function u, right? But there is a problem. In this function, we have t of x, but we don't know what is the value of t of x. So let's solve and find the value of t of x. When we succeed in finding the value of t of x, we'll come back here and we place it. We have solved. Okay, that means we have solved for this equation, right? Good. Now let's go. We have the function u is equal to minus x squared y plus x y squared minus 2y plus t of x. Now, let's differentiate this function partially with respect to x. We have t of x and we are looking for t. So we differentiate this partially with respect to x. Okay, now let's go. That means we're going to say the partial derivative of u with respect to x is equal to, in this function, we take every other variable constant and differentiate only x. Okay, now let's go. Here we have minus x squared y. When we differentiate with respect to x, it's going to give us minus 2xy. Okay, good. Then we have xy squared. When we differentiate with respect to x, it's going to give us y squared. Then plus, we have minus 2y. There's no x. When we differentiate, it's going to give us 0. Then we have plus. This is t of x. When we differentiate, it's going to give us t prime of x. Hello? When we differentiate t of x, it's going to give us t prime of x. Now, let's call this equation 4. So here now we have the partial derivative of u with respect to x is equal to minus 2xy plus y squared plus t prime of x. All right, good. Now, we have found the partial derivative of u with respect to x, and we call this equation 4, right? Good. Now, let's go again. Let's go to the first and the second equation that we have. The first equation that we have, we say the partial derivative of u with respect to x is equal to y squared minus 2xy plus 6x. All right? We say equation 1, right? Good. And then we have equation 4. The equation 4 that we have, we say the partial derivative of u with respect to x is equal to minus 2xy plus y squared plus t prime of x. Please, let's compare these two equations. Let's compare these two equations. So comparing the two equations, we see that they are almost the same. So comparing them, we see that t prime of x is equal to 6x. Hello? We see that t prime of x is equal to what? 6x. I told you that we are looking for the value of t of x, not t prime of x. But here we say we have t prime of x is equal to 6x. So that means when we integrate this t prime of x, this prime is going to go, because we say that the differentiated form of t of x is t prime of x. So since it is differentiated, when we integrate it, that means we neutralize that differentiation. All right, it will come back to normal. So that means we integrate both sides with respect to x. So that means we're going to have the integral of t prime of x dx equal to the integral of 6x dx. So when we integrate the left hand side, it's going to give us t of x. And when we integrate the right hand side, it's going to give us 3x squared plus c. Hello? It's going to give us 3x squared plus c. So here we have found the value of t of x. So let's go to equation 3, where we need the value of t of x. Then we replace it. So replacing it or substituting equation 5 into equation 3, we say that we have u is equal to minus x squared y plus xy squared minus 2y plus 3x squared plus c. All right? Yes. Now let's rearrange this very well. That means we're going to say that u is equal to xy squared minus x squared y plus 3x squared minus 2y plus c. All right, yes. So this is the value of u that we are looking for, and then this value of u is the solution to the exact equation that we have. Is that clear? Yes. Now, I told you we are going to take the two sides. Where we have equation 1 and equation 2, we picked equation 2 and solved, and we obtain u, right? Good. And I told you that we can also use equation 1 and we also obtain the same value of u. Okay? Now, let me show you. Let's do it together. Let's take it, okay, so that you will understand very well what I'm trying to say. Okay, we said equation 1 is the partial derivative of u with respect to x, which is equal to y squared minus 2xy plus 6x. And then the second equation, the partial derivative of u with respect to y is equal to minus x squared plus 2xy minus 2. We say this is equation 2, right? Good. And then we worked with equation 2 and we obtained u. Now let's work with equation 1. Let's see whether we are going to obtain the same u. All right? Good. Now, picking equation 1. The equation 1 says partial derivative of u with respect to x. And we are looking for the function u of x, comma y. And then this place we have the partial derivative of u with respect to x. That means we are going to integrate this function with respect to x so that we will find our u. Hello? We differentiated partially with respect to x. That is when we have this function, right? Good. But now we are looking for u. That means we are going to integrate with respect to dx so that we'll find the function u. Now let's go. We say the integral of partial derivative of u with respect to x dx equal to the integral y squared minus 2xy plus 6x dx. All right. So when we integrate the left hand side, it's going to give us u. And then when we integrate the right hand side with respect to x, it's going to give us xy squared minus x squared y plus 3x squared plus, we're supposed to have c, but here we are not going to call it c. We're going to say t of y. Hello. We're going to call it t of y. Now let's call this equation 3. So the function u of x comma y is exactly what we are looking for. But in this case, we have a problem, t of y. We are looking for the value of t of y. We want to find the value of t of y so that our function u of x comma y will be complete. Okay, good. Now let's go. This function that we have u, let's differentiate it with respect to y. We have t of y and we are looking for t of y. We want to find the value of t of y. So that means we are going to differentiate this function u partially with respect to y. Okay, so that means we're going to say the partial derivative of u with respect to y is equal to, when we differentiate x y squared with respect to y, what is going to give us? It's going to give us 2xy. Then we have minus, when we differentiate x squared y with respect to y, is going to give us x squared. Then we have minus x squared, right? Plus, when we differentiate 3x squared with respect to y, that means this 3x squared is constant. So we're going to have 0. All right, good. Then here we have t of y. When we differentiate t of y, it's going to give us t prime of y. Hello. It's going to give us what? T prime of y. Now let's call this equation 4. All right, good. So this equation 4, we say the partial derivative of u with respect to y is equal to 2xy minus x squared plus t prime of y. All right, good. Now let's go to the beginning where we have equation 1 and equation 2. So equation 2, we have the partial derivative of u with respect to y is equal to minus x squared plus 2xy minus 2. Is that true? Yes. And then here in equation 4, we have the partial derivative of u with respect to y is equal to 2xy minus x squared plus t prime of y. So let's compare these two equations. Let's see how do they look alike. Comparing equation 2 and equation 4. So we see that we have the same partial derivatives and we have the same minus x squared and we have the same plus 2xy, and then the slight difference is minus 2 and t prime of y. So we can say that t prime of y is equal to minus 2. Hello, t prime of y is equal to minus 2. But we are looking for t of y, not t prime of y. But in this case, we see that t prime of y is talking about the derivative of t. So that means for us to take the t of y, we are going to integrate. So we integrate, the derivative will go. Alright, so that means we are going to integrate both sides. So when we integrate both sides, we're going to have the integral of t prime of y dy equal to the integral of minus 2 dy. So we integrate with respect to y. Alright, good. So when we integrate t prime of y, it's going to give us t of y. And then when we integrate minus 2 with respect to y, it's going to give us minus 2y plus c. Hello, when we integrate minus 2 dy, it's going to give us minus 2y plus c. So we call this equation 5. Good. So here we have found the value of t of y. Is that true? Now let's go to equation 3, where we have our u, but we don't know the value of t of y. But now we have found the value of t of y, which is minus 2y plus c. Now let's go and bring it here and then add that value. Okay, so we are going to say that u is equal to xy squared minus x squared y plus 3x squared minus 2y plus c. Hello. So here now we see that we have solved and we obtained the function u of x comma y. And then the first one that we obtained, we have a little problem, which is the value of t of y. And now we have solved for t of y and we substitute. So substituting for the value of t of y, we see that the function that we are looking for, u of x comma y, is equal to xy squared minus x squared y plus 3x squared minus 2y plus c, which is the same thing when we follow the other method. Hello. Yes, we have solved and we see that the function we're looking for, u of x comma y, is equal to this. All right. Yes, so this is the solution to the exact equation that is given to us to solve. All right. Yes, thank you very much for watching. Please, if you have not subscribed, please click the subscribe button, like, and try your possible best and share our videos. All right. Yes, stay blessed. Let's take more examples on differential equations.